Hello, good afternoon everyone. How was your PT1 exam? Okay, is it easy? What about maths exam? No one got 20 mark, I think. 19 or 80 top mark. Anyway, yesterday I sent that answer key also. All of you understand your mistake? Okay, now let us start our next part from the third chapter that we already started understanding quadrilaterals. Some part we discussed. Now today we can discuss about diagonals. Okay, diagonals. Before that, what we discussed polygon. What is polygon? Polygon is a simple closed curve made up of only line segments. Now, what about diagonals? Diagonals of a polygon, how we can describe? Now, let us consider one polygon. I draw one polygon as a rectangle. Okay. Then, here for a rectangle, all of you know how many vertices are there? 4 vertices are there. And if we draw one vertex, if you draw a line segment from one vertex to another, its opposite vertex here. That means from one vertex, if you draw a line segment from one vertex to its non-consecutive vertex, that is, if it is the consecutive vertex of A, it is B. Another consecutive vertex of A is D. But C is not consecutive vertex of A. That is, after B only comes C. A, B, C. So, a line segment drawn from one vertex to a non-consecutive vertex is called, this line segment is called diagonal of that polygon. Just like we can draw one more diagonal in this rectangle, that will be BD, the line segment BD or DB. So, in this case, for a rectangle, there will be two diagonals. So, for any polygon, we can draw diagonals. If it is another polygon with 5 sides, here also we can draw diagonals. So, here we name this A, B, C, D, E. Okay. Then, if we draw a line segment from A to C, this is a diagonal. This is A to C. AC is a diagonal, and another diagonal also we can draw here. AD. AD is another diagonal. AC is another one. So, two diagonals we can draw. In this case, pentagon. So, this type we can draw as many possible diagonals in different polygons. So, what is the definition of polygon? Polygon is a line segment drawn from one vertex to its non-consecutive vertex. That is mean by diagonals of a polygon. Now, another next part is convex and concave polygons. What is the difference of two types of polygons we are discussing? Convex and concave polygons. Convex polygons means, so this suppose same figure we can draw. If it is a rectangle, if we draw that diagonals of this rectangle, the two diagonals are in the inside part, that's interior part of that rectangle. See, when we draw that diagonals of these, that two diagonals are in the interior part of that polygon. Interior part, all of you know, and what is the difference of interior part and exterior part? These parts is called the exterior part of this polygon, and the inside part, that is called the interior part of that polygon. So, when we draw the diagonal of this polygon, that full part of that diagonal is interior part of that polygon. In this case also, when you look this, here we draw two diagonals, that two diagonals are in the interior part of this polygon. Now, suppose another polygon, I draw this type. This is also one polygon, isn't it? This is made up of only line segment, and it is also a closed figure. So, this is also another polygon. If it is named P, Q, R, S, T. Okay. So, now if you draw one diagonal. We can draw one diagonal from P to S. P to S we can draw one diagonal. Another diagonal we can draw P to R also. And this also a line segment drawn from one vertex to another non-consecutive vertex. So PR is one diagonal. Another diagonal PS is also one diagonal. Now TR also another diagonal. Okay. So one more diagonal here we can draw QT also another diagonal. Now we can draw one more diagonal in this figure polygon, in this polygon. Can you imagine? One more polygon is remaining in this. One more diagonal is remaining in this polygon, which is that we can draw one diagonal from Q to S also. This is also one diagonal of this polygon. But can you find out the difference of this diagonal from the other diagonals of this? Here we draw some another diagonals also. That is PR one diagonal, TR another diagonal, then QT one diagonal we draw. But last we draw that diagonal QS. What is the difference of the diagonal QS with the other diagonals? Can you imagine that? We know all other diagonals are on the interior part of that diagonal, but QS is on the exterior part of that polygon. All these diagonals are interior part of this polygon, but the diagonal QS is on the exterior part of that polygon. So such polygons are called what? Concave polygons. What is that? Concave polygons. That means if any one of the diagonals are on the exterior part of that polygon, such polygons are called concave polygon. And in this case, how many diagonals are there? That full diagonals are on the interior part of that polygon. Such polygons are called, what is? Convex polygon. Convex polygon. Okay. So if you draw one hexagon or octagon, all any type, any polygons we draw. Now you look, if you draw, you can draw different diagonals. Here 2, 3, these 3 diagonals we draw. That 3 diagonals are on the interior part of that polygon. So this is which type of polygon? Convex or concave? This is convex. So in this type of another polygon, you look. What is the name of this polygon? Can you say the name of this polygon? What is the name of this polygon? Count how many sides are there. 1, 2, 3, 4, 5, 6, 7. Is it 1, 2, 3, 4, 5, 6, 7, 8 sides are there. So it is an octagon. Okay, it is an octagon. But you know, when we draw these diagonals, this is also another octagon. 2 types of octagon we can draw. With the 8th side we can draw another polygon also. 1, 2, 3, 4, 5, 6, 7, 8. That is, these 8 sides are there. Okay. So this is also one octagon. This is also another octagon. Both are octagons. But when you draw the diagonals of these octagon, all the diagonals will be on the interior part of that octagon. But when we draw diagonals here, you look, one diagonal we can draw from here. Here also we can draw another diagonal. So these polygons are called what? Concave polygons, and this type of polygons are called convex polygon. Okay. So next, so now we discussed diagonals of a polygon and what is the difference of convex polygon and concave polygon, and one more type polygons we want to discuss, that is regular polygon and the irregular polygons. Regular polygon, that you know what means. Regular means same. Okay. So polygons which are equilateral and equiangular. Equilateral and equiangular are called, what is the name? Regular polygons. Suppose here we draw one rectangle. Okay. And another polygon I draw a square. Now in this case you look, what is the laterals means sides. What is the length of this side? Are they same? For all sides it is not. Here only opposite sides are equal. But when we consider the angles, all angles are 90 degree. Okay. So it is equiangular but not equilateral. Okay. If it is same sides, if the same length sides, we can call them equilateral. But as they different length, we cannot call them equilateral. It is a polygon which is equiangular but not equilateral. But in this case of square, all sides will be same length. So all sides will be same length. So it is equilateral, and also all angles will be 90 degree. So it is equiangular. Such polygons are called what? Regular polygon. Regular polygon. And if it is not equilateral and equiangular, such figures are called, such polygons are called irregular polygon. Now clear the difference of that? If polygons with the equilateral and equiangular, then that polygons are called regular polygon. Otherwise they are called irregular polygon. Now in this case of hexagons, regular hexagon, if it is 6 sides, if 6 sides are equal, 1, 2, 3, 4, 5, 6. If these 6 sides are equal, then we can call them regular hexagon. Okay. And if it is 5 sides of a pentagon are equal, we can call them regular pentagon. Regular means same sides and same angles. Okay. So that much we discussed today. First one is diagonal, and next we discussed what is convex and concave polygons, and last we discussed what is regular polygon and irregular polygon. All of you clear well? Okay, thank you.